Okay, let's talk a little bit about scales of the universe. Our goals here are to try and get a sense of how vast the universe is by looking at some video to illustrate the relative scales of objects in the solar system and in our universe, as well as the distances in our universe, and also build our own scale model of the solar system and put it on Weber State's campus so that we can get a sense of how big the universe is and how big our solar system is relative to something that we have some familiarity with. Okay, so the first thing I'd like you to do is take a moment to watch the Powers of 10 video that I've posted in the introduction topic. This is an older video. It was done in the 70s, but it's a fantastic way of seeing the relative distances of things in the galaxy or in the universe. And then secondly, I want you to take a moment to play around with this tool I found called the scale of the universe. This is something that talks about the relative sizes of objects. And this is a fun little tool because it just shows, just things that you might be familiar with. A human, a giant earthworm. I just learned about those the other day. Beach balls, dodo birds, and you can zoom in and out. If I zoom in, you can see the common earthworms, quail eggs, go way down to infrared wavelengths, skin cells, and all sorts of things. But if you zoom out, you can get out to astronomically interesting stuff. Planets and asteroids and the Earth itself, all the way out. So just play around with that to get a sense of the different scales of the sizes of things in the universe. And the reason we have these two videos for you to see is that talking about distances in the universe, talking about the sizes of things, in order to get a relative size of objects, you need to use a different scale than if you're looking at relative distances. But I wanted to talk a little bit about how you make a scale model of the universe, or any kind of scale model for that matter, because it does require some mathematical manipulation. Okay, so for scales of the universe, let's first take a look at what it takes to make a scale model. So anytime you want to make a scale model, you're pretty much asking yourself two questions. You're asking yourself, what is the scale that you want your model to have? So for example, in our solar system, I could say if the sun were the size of a stop sign, so that's instantly sets my scale. It means that everything in my model will scale such that the sun is the size of a stop sign. And then I ask a second question. I say, what are the sizes of the other objects in that scale? So if I say if the sun were the size of a stop sign, then Jupiter would be the size of, and I calculate out what Jupiter would be the size of. So in our case, if I set the size of the sun equal to a stop sign, that's one stop sign is equal to one sun. A stop sign is 0.75 meters in diameter. Got that off of Wikipedia. The sun is also 1.39 million kilometers in diameter in reality. I got that off of Google. So I set 0.75 meters to 1.39 million kilometers. And then if I divide through by 0.75 meters, I get that 1 meter is equal to 1.85 million kilometers in our scale model. That's called the scale factor. That means that every meter on our campus is going to represent 1.85 million kilometers. So what do I do with this information? Well, once I decide what my scale is, then I can answer the second question. If the size of the sun is a stop sign, then Jupiter would be the size of. Well, I look up on Google that one Jupiter is 143,000 kilometers in diameter. And since my scale factor is 1 meter is equal to 1.85 million kilometers, I take Jupiter and multiply it by that scale factor. That scale factor is 1 over 1.85 million kilometers. So I take Jupiter's size, which is 143,000 kilometers, multiply it by 1 divided by 1.85 million kilometers, and if I do that, I get 0.1 meters. So 0.1 meters, 10 centimeters, and 10 centimeters relative to my sun, which was 75 centimeters. So it's about the size of an orange on our scale model. So if I were to do this for the Earth, right, I can go ahead and do this calculation. I would look up what size of the Earth is. I would multiply it by my scale factor, 1 over 1.85 million kilometers, and I would get the size of the Earth. So go ahead and do that calculation and see what we get. I think you'll find that it's about the size of the head of a nail. Okay, so here's our Weber State campus. This is what you're going to be using for your scale model of the solar system. It's approximately 1 kilometer square, which is convenient, and you can start anywhere you want, putting your sun in the solar system on campus. instead of doing this, in addition to doing the sizes of the planets, you're also going to do the distances. So you'll take the radius of the orbit and you'll use the same scale factor, whatever scale factor you like. I used the stop sign, and you can scale the model accordingly. Okay, let's go ahead and get started with the activity. You'll find it as the first activity in your book, and you can get started building your own scale model.